For the next problems, they want us to find the indicated function values. And they really give us three different functions here. We have f of x is equal to 3x minus 2. And that's really how that's said. This is f of x. And that's just really the name of the function. It doesn't mean f times x, even though that notation also could mean f times x with parentheses, but that does not mean that here. So this is just the name of the function. This is just f of x. This is our g function, or our g of x function, and this is our h of x function. And these could be different every single time. So it's not like f of x will always be 3x minus 2. For these problems it is, but they could define f of x to be 7x plus 18 or whatever. So they could be different every time. But for these exercises, this is how they're defining all of these functions. So if you look at number 6, this says f of 0, which that is kind of a fancy way of saying take the f function and plug in 0 wherever you see x. So many times in math we've plugged in numbers into equations and figured out what they're equal to. That's essentially what we're doing here. So they're identifying the function that you want to use as f, so 3x minus 2, and they're just telling you to plug in 0 wherever you see an x. And 3 times 0 is 0, minus 2 will give you negative 2, and that'll be your answer. So a lot of these things with functions and functional notation, it's really nothing new. They're just phrasing it in a different way. And they're phrasing it in a different way because if you have to go on in mathematics, they basically refer to everything as functions. That's kind of the language or the lingo. So this whole notation is something that really never goes away if you keep going on in mathematics. With 7, it says f of negative 5, which again, that means that we're still dealing with the f function. So I don't even care about the g function, I don't even care about the h function. And I'm plugging in negative 5. So 3 times negative 5 minus 2 is going to be negative 15 minus 2, which is negative 17. It's not always just numbers that we're plugging in. Sometimes it's other variables. So they want us to plug in 5a into the f function. So I'm going to copy the f function down. You don't always have to copy the original function down if you don't want to. That's okay if you don't. So this is 3 times 5a minus 2. So you're plugging in whatever's in here into x, wherever you see x. And then you want to simplify. So 3 times 5 is 15a minus 2, and there's really nothing more I can do to simplify this, so this is okay. And then lastly, f of a plus 4, again it's referring to the f function, and you don't need to write it if you don't want to. But where I see x, that's where I want to plug in a plus 4. So 3 times a plus 4 minus 2. And then if I distribute, this is 3a plus 12 minus 2. And then if I combine like terms, it's 3a plus 10. So these are the functional notation for plugging in values into equations. Let's actually do another one where we're not using the f function. Let's use one for the g function. So if I go to number 12, this is g of negative 5. So the g function is 3x squared plus 4x minus 2. And wherever I see an x, I need to plug in -5. So 3 -5 squared plus 4 times -5 minus 2. Okay, -5 squared is a positive 25. So that negative goes away. This will be minus 20 minus 2. So that'll be 75 minus 20 minus 2, which will give you 53. So again, the letter really identifies the function. So g of -5 means you're plugging it into the g function. F of 0 means you're plugging it into the f function. If they say h of something, so like 14 is h of 0, you would plug it into that function. So you're only dealing with one function at a time.